Hey everybody, Mr. Sharkey here. Today I'm going to walk you through what exactly we want you to do for this heating curve simulation. In some classes we ran out of time, in some classes we got to this, so if this is review, that's okay. We just wanted to kind of walk you through the first step and what exactly we want as we work through this simulation. So up here at the start of the simulation, we want you to go through each of these boxes and kind of define each of these terms for each different state of matter. So when we think about a solid and the spacing, we're talking about the space in between particles. So if you could briefly fill in what the spacing for solids, liquids, and gases are, mainly focusing on what the differences are. Same for the arrangement. When we're talking about the arrangement of particles, we could talk about how rigid or fluid those particles are. The range of motion has to do with how much those particles are moving. And attractions is referring to the level of attraction. So when are particles most attracted, when are they least attracted? And then we get into the actual heating curve. So this is where you want to use the simulation. Now the simulation is really good because it does a good job showing us what's happening at the particle level. But there are a couple issues with it that make it not perfect. So let me walk you through exactly what things should look like and how it's going to work. So if we flip over to the simulation, it is if we press play here, we're going to be able to set up and choose our water going from a solid all the way up to a gas. So I want to set up the simulation so it looks like this. And then what I want to focus on are these particles. If we look, these particles are showing a water molecule, which is a little bit more specific than we've been so far. We've just been focusing on individual particles. So as we draw particle diagrams, you just need to draw individual circles for each piece of water. We don't have to draw the H2Os like they are drawing. We can simplify things a little bit. If we look at it now, I can see that my solid particles are kind of bouncing back and forth. So there's a little bit of movement as they vibrate. And what I'm going to do is I'm going to go ahead and press play. And I'm going to keep track of what my particles are doing as they move in between these different regions of the graph. So as I press play, we'll see that the temperature starts increasing. If I look at changes, I'll notice that the water particles are maybe vibrating a little bit faster, but there's no dramatic change here while they're a solid. They're still a solid the whole time. They might be spreading out a little bit further. But as I get into the melting phase, we'll notice that some of those particles start to break free of the solid arrangement, and they should start to kind of float around and flow a little bit on their own. So when I come back to my handout, what I want to do in region A is I want to draw a particle diagram for this stretch of the graph. So I want to draw a particle diagram early on in section A and then a little bit later in section A. So if I were to draw this particle diagram for A, I would show that it's a solid both times. And if we think back to the simulation, we didn't really notice any dramatic changes. So we could draw a solid in our before and then a solid in the after. The only real difference that we noted, we said that they were vibrating a little bit more and that our particles might have spread out just a little bit because as they heated up, our ice started to expand. So that's all we really want you to do is think about what's happening at the particle level in each of these regions. So if we wanted to move on to region B, at the beginning of region B, we had mostly ice, but a little bit of water. So we would want to show that most of our particles are ice, and then some of them are liquid water. And then we'd want to draw a second particle diagram towards the end of region B. We do the same thing for C, D, and E. When we're drawing particle diagrams of solids, we don't really need to focus on the motion because we know that solid particles are vibrating. They're not standing perfectly still. But if we try to draw in those vibrations, our particle diagram can get a little cluttered and get a little messy. So instead, we can just focus on the spacing of the solid. And then as we get into region B, that's where we can really start to show some differences because we'll have a mixture of solid and liquid as it's melting. And then we'll leave C, D, and E up to you. What I recommend you do is you watch through the simulation from beginning to end. And then after you finish watching the simulation, you should be able to finish things out. Thank you.